Okay, so just to get an idea of how I should pace myself, how many of you have finished diploma? Please raise your hand. How many have finished the programming diploma? How many have finished the data science diploma? How many of you finished foundation? Who hasn't done Python, intro to Python? Okay, great. So you might be hearing a lot of things that do not perhaps make sense. And I wouldn't say that ignore it or forget about it or something that never works. So if there's anything that is clear, not clear, feel free to interrupt, right? If there's anything you don't understand, okay, those of you who haven't done Python, are you currently doing it or are you taking it up this term or what? Like, you understand generally how Python works or like it's not completely blank, right? Perfect, that's good enough. And that's kind of the audience that we want to cater to because in courses like Introduction to Python, our task is to ensure that only the best possible Python programmers can pass. Because if you are not significantly good at Python, there's not much that you can do over the next 2 years because data science and programming applications is pretty much all Python, right? There's very little that you can do without Python. But the interesting thing is that later, 5 or 10 years later into your career, you'll realize that there is less and less dependence on Python as a language itself, or any language. It doesn't have to be Python. Whatever stack you're using, there is less and less dependence on the language and more dependence on libraries and frameworks and toolkits and things like that. You rarely have to build things from yourself. So one big problem that I have with programming interviews and stuff is like they'll ask you to like reverse a list or something, which you're never going to do yourself. They'll ask you to implement graph traversal algorithms and how many of you have done PDSA? Okay, great. So those sort of things are important because from a theoretical perspective, of course, not to say that they're not important at all. Every day as a data scientist, there are two aspects of data structures and algorithms that matter most. One is picking the right data structure for a task. And the second is given two algorithms to solve a problem, commenting on the relative efficiency of them. Those are the two things. If you know how to do that, pretty much all of PDSA is done. But of course, it has to be a holistic course. It has to be a complete course. And when you when you pass that course, you have to be able to say that I know the stuff, which is why they're slightly, challenging to begin with, and they should be, because if you deal with the challenging aspects now itself, then later you'll be very comfortable. Which is why, the complexity of the language is something that we'll try to avoid today. What we are going to do is try and make things very, very simple and see how that ties directly into what I call craftsmanship. So, you see, essentially, learning how to use a tool is easy, but mastering that tool and, having an artistic sort of approach towards how you write your code, looking for maybe some mathematical or even, literary elegance in your code, that's what I mean by craftsmanship. So, okay, enough. I guess let us start with a warm-up exercise. Is the code visible? Any idea what this does? Oh, and by the way, you are going to be doing most of the talking, not me. So feel free to speak up absolutely anytime. And in fact, I'd encourage you to, because it's noisier, please occupy the front rows as much as possible. Let me give you a hint. Don't go by the code, go by the variable names. Any guesses what does this piece of code do? So there are things like queue, you can notice that there is a queue, right? And certainly you're pushing something into the queue and you're popping things out of the queue. And then you can see words like visited. What does this remind you of? It's either BFS or DFS, right? Depending on whether it's a queue or a stack, it's one of the two, right? But okay, let's take a look at the queue. There are two methods. One is add queue and del queue, right? Adding something to the queue, deleting something from the queue. Okay, when you add it to the end because it's a dot append, right, to a list. And when you remove it, you do a pop of 0. So what is it? Is it a queue or a stack? It's a queue, right? So out of BFS and DFS, where do we use the queue? Breadth first search. This is breadth first search, essentially, right? Now here's the question. Let's try another quick example. I hope this works. And I'm not too sure. Is the screen visible? First problem with ChatGPT or any LLM, they tend to be extremely verbose. So you have to prompt it to be very, very precise. Good enough? Code implements breadth first search on a graph using a custom queue class derived from Python's lift, provides methods to add to the queue, remove from the queue. Parse function takes an adjacency list starting at node root, returns a dictionary visited, indicating whether each node has been visited or not. Alright? Fair enough. How do I make this shorter now? Okay, or how many irrelevant or redundant things can you spot here? How do we make this better, precise, more readable, something that, shorter essentially? What can we eliminate? Okay, I think the first thing we can eliminate is the queue. We don't need it. Because we can straight away use a list. We don't really need. You see that this is a class that subclasses a list and it's just using the list itself. So all of this is not required. So wherever I have queue, I am just going to maybe change it to an empty list, right? And now this is my queue. Where all do I have instances of it? I just have to change the behavior at those points, right? So instead of add queue, what do I do? Fine. What's the next? While not queue dot is empty. Exactly. While length of queue. Oh, this is interesting, rather. Like, is there a way to make this even shorter? Length of a iterable. While length queue, exactly. Could you explain why? 0 is always false. Anything that is not 0 is anyway a boolean. So, of course, and whatever comes after while will be cast into a boolean automatically. So, right? So, we'll say while the queue has some length, keep doing something. Even shorter, right? Okay, del Q. Now this is interesting. It's a queue, so you have to pop things out from the left end. What can I do here? I can just copy what I wrote in the class earlier. Right? I can do q dot pop of 0. And here again, I can do append. Done. Now I can get rid of this whole class. My code, okay, let's take a look. Yeah, well, 12 lines shorter. And code brevity and why lines of code matters, especially in enterprise settings, is something we're going to come to. Okay, one other problem with using queues like this. You see, Python queues are a little bit like arrays and they are a little bit like linked lists. And especially when they behave like linked lists, popping something from the left end tends to be a very expensive operation. It has to recompute lots of things. So there is a very interesting data structure in the standard Python library called a deck, right? Anybody heard of that? Or the collections module, for example. So perhaps, oops. So a deck is just a list that supports fast pushes and pops at either end. A list can be used as a stack very well, but it may not be able to, you may not be able to use it as a queue. So for example, if you were to just delete the first element of a list, then the initializer has to be moved. And then, the pointer to every other, although you are not doing it yourself because this is not C, Python does it automatically, but it's still expensive because it has to go on allocating pointers across, right? A deck is something that makes this easier. So you can have a deck like this, and instead of a pop, you can have a pop left. That's a fast pop from the left end. And append works as it is, right? Too many blank lines, okay, doesn't matter. By the way, this is something called a styler or a linter, right? So you can configure your editor to have uniformly styled code, not super relevant right now. Right? So now we have perhaps efficient code. Okay, let's focus on this. How do we make this shorter? What can we, or rather better generally? We can do it in one line. How? Okay. Dictionary comprehension. Yeah. So just like there are list comprehensions, you can have dictionary comprehension. So I can say visited is vertex false, that a given vertex is not visited at the beginning for vertex in A. Why am I not using A dot keys? By default, dictionaries will iterate over their keys. If you have to do it for values, you have to do iter items and other stuff, right? Or use dot values or something like that. Again, 2 lines, saved. And note that I am using the word v for vertex. I am not just using v because v could be value k comma v is some key values we use all the time. But this is graph traversal, so using proper variable names is very critical, right? And q is that, and my visited of root is true, fine, this is okay. Now I could do q dot append root, or I could just initialize like that. So it's already in the queue. Another line saved, okay? And while length of queue, pop left for k in aj, if not visited of k, then visited k is 2, and that's it, we're done. Or unless there's some other part where you think we can save some more code and make this precise. Anyhow, so this is what we have now, and note that all this huge thing is what we had earlier. Can you come up with, let's say, 3 reasons why this should be preferred over this. And there are three reasons, or at least two that I can think of. You think this is more readable? Okay. You have to figure it out, sure. What else? Why is the earlier one better than this? I mean, I'm sure all of us can list tens of reasons why this is better than the earlier one, but let's be the devil's advocate here and figure it out. We do not have to import anything. Yes, maybe, but then, where does it stop? The problem is like, okay, I created a custom class. Well, okay, let me put it this way. Importing is cheap. Doesn't cost us anything. What else? Like? These already are in C. So, I mean, you have C bindings for pretty much anything that exists in Python, any variable in Python. The thing is that this is the sort of stuff that people write when they want to teach you, right? Nobody really uses this kind of code generally, and that is the case. This is actually copied from a PDSA lecture. And one of the, I'll come to, how you can parse PDSA videos against unreadable code and all that. Is anybody doing PDSA right now in this term or has recently done it in the past term? Okay. You're going to start. Okay, cool. All right. So, yeah, let's take a quick look at what we did. We got rid of a custom class. We found that there is something that already exists. We used it. And we wrote, we were a bit more aware of the data structures that we are using. And whatever they can automatically do, like list comprehensions, for example, or you don't have to iterate over keys explicitly. We use features like these to make our code shorter. Okay? Good. Slightly simpler access. Okay, I do not want to save this. All right. By the way, let's just ask this. Okay, do you see what it's doing? I asked it to make the code more readable, but how is it doing that? Variable names, right? Which is good, by the way. I used Vertex, they called it node. But there are certain things that, are a little silly. What are they? Look for the variables names that have an underscore in them. So you look at things like this. Adjacency underscore list, start underscore node, current underscore node. If it's a list, I'll know it's a list. There's no point telling me extra that it's a list, right? Or anybody who knows a little bit of Python, I can just say visited list or whatever, something like that, right? Current node, I know it's a node. So that's redundant. And whenever you have these appendixes like, something like key value dict or adjacency underscore list, that is pointless because from the behavior or from the interfaces, what you're doing with that variable itself tells you what kind of a variable it is. So this is sort of irrelevant. You wouldn't say like, if you're like, I don't know, doing, registering people for this workshop, you wouldn't say like first name underscore string or second name underscore string, roll number int, right? That's not required. From the behavior, see, there list, you can only do two things. You can push, pop, calculate its length, right? Of course, you could calculate length with a dictionary also, so there is some overlap between, what you do with an object, disambiguating that object. But for the most part, this is not required. So I asked it to make it more readable. This is what it did. Let's see what it does. No great improvement. It practically is reiterated. Okay, let's see. It is summarized helpfully, the changes made. Simplified method names, rename. It's renaming. I don't want that. Okay, then make it shorter. Let me not do that. Okay, I can't tell what it seems to have removed one method. Okay, is empty is been removed, which is what we did. And again, by the way, while queue, this is interesting. An empty list is anyway false again. So we can go further back and, say that so does this make sense? These are all equivalent, right? So we did not even need if length of something, like if list straight away. If it's a non-empty list, if it has one element, it's a true, right? Anyway. So you see, it's not really figuring it out that, say, avoid the use of a custom class. Now I'm straight away giving it the answer. There it is. So this is what we ended up with. So you see, depending on your prompting, it's going to give you different answers. So there is the refactoring that you do for multiple different things. You do refactoring for readability, you do it for making it concise, and you do it for making it publishable, something that you can, either teach with or publish to people. And at the same time, it's compact and readable and maintainable. By the end, I hope to have convinced you that all three are actually the same thing, right? ChatGPT doesn't know about that. It will chase those three different metrics independently and it will come up with three independent results. It's not going to understand that one of those things, and we don't expect it to, because these are things that you start appreciating only when you have experience with a lot of code. Less code is always better, right? All right. Let us try another. Can we shut the windows? Is it possible? It's too noisy. Oh my god. I doubt it's going to make it any hotter, so we can might as well. Who has seen this movie, A Beautiful Mind? Does this remind you of something? So there's a scene in that movie where John Nash is supposed to be this really irritable and bad lecturer. He's a genius, but he's a bad lecturer. and he enters a very hot classroom in a t-shirt or something. He's not he's wearing just exactly one layer of clothing because it's so hot. And exactly this situation is happening. He's outside and people are digging with jackhammers there. He said, it's the AC isn't working. If I have to keep the windows open, it's too noisy. We are not having the class. And one student just gets up and pokes her head out and just yells to that guy, could you please go and work somewhere else for 1 hour? And then he says that, as you'll notice in this course, there are often more than one solutions to any given math problem. So, anyway, so yeah, next exercise. We are going to try and build a function that solves quadratic equations, right? How would you do it? What is the general form? Fine. How do you solve this? Well, we know how to solve it, of course. What do you do in Python? Tell me what to type. No, I know the formula. Tell me what to type. Maybe better because, another thing that, when you're starting to learn Python is there is this tendency to always get input from the input prompt. That's good if you want to make interactive applications. But let's say we just want something that generally works for everyone. Just like the solution to this is general, it will work for every parabola, right? Don't stand up, please sit down. And again, this is why I said please come and occupy the front row, it's barely audible. Discriminant, yes. Discriminant is the minus b by 2a. So what is minus b by 2a called? Sum of the roots, okay. And the other is what? Product of the roots? Cool. But anyway, what do we type? Function, straight up. Simplest thing we can do is you write a function. Now that function you can use to take input and pass it to the function. Somebody wants to use the function directly in some other module, that's always the possible. So you should always be writing functions. What you do with them is a separate issue. No matter what okay, the worst possible way to solve this is a equal to none and then b equal to none and then c equal to none or something like that, or some int or whatever. And then it's a well, actually no, it's like input of enter coefficients, let's say. How do you take multiple inputs? You call input multiple times, right? Yeah. Or actually, I can say for I in range of 3, x equal to, well, I could do something like float of that. This is fine. But what do I do with x now? X will be ABC, right? So what do I do with this? I could just store them in a list, right? So I don't need all of this. And then I can do unpacking, right? You see, I don't know, we work together, so we spend only like 30 seconds on this, but we are distracted by this. We are not solving the real problem right now. And this happens a lot. So, often what happens is people tend to get distracted by interfaces. How will the user interact with this code? Doesn't matter. Tackle the first problem, right? And give the users the option to actually use it anyhow we want. So, yeah, let's write a function. So, let's call it solve. What inputs does the function take? Alright, next. What do we do with ABC? Which is, how do I do this? Don't tell me algebra, tell me Python. We can do that. So, return what? You see the conflict here? It's precisely the, I'm so sorry about this. We can return it. We have to because it's two root, right? Two roots. Let's say return x1, x2, right? Now, this is a very real conflict that happens between programmers all the time. Do I write the whole expression in one line? Do I compute x1, x2 separately? Which is why whenever you write code, have it reviewed by someone, right? So, okay, well, then obviously the only thing to do is compute x1 and x2. So, x1 is minus b plus square root of, now square root has to exist. So, I can say from math, import square root minus b plus square root of b square minus 4 star a star c. Obviously. Yeah. Is it okay? No, exactly. Okay. Next. Literally the same thing, right? So I can say x2, here it becomes minus. Ignore what the errors say, our code is fine. Okay, it works, it's valid. This will solve quadratic equations. How can we make this even more readable? When you want to make things more readable, look for repetition and redundancy. We literally copy pasted one line and changed one character. Can we do better? We are kind of there in fact. The discriminant and the product and sum of two roots. Let's see. I would say minus b by 2a is sort of like the, what's the geometrical name for that thing? No, like if this is my parabola, there is a name for this line, right? Axis? Okay, fair enough. Is that correct? Actually, no, sorry. I'm sorry. No. This line, what is the name for this line? No, not the y-axis. Y-axis, let's suppose, is here or whatever. Axis of symmetry, and but I was wrong. I was looking for minus b by 2a. It is not this line that matters, it's that value of x being minus b by 2a, which is, what is the sum or product? Sorry? But this is minus b by 2a, right? Or am I getting something wrong? This is correct, na? Take it. Let's just call it, I don't know, midpoint or something. So I can say something like, and that is the midpoint, and there will be a root to its right and root to its left, if roots exist. Okay? So I'll say mid is minus b by 2 star a. And what is the other part? Well, we have a midpoint, so let's call it an offset, and that would be this. Now what do I return? Mid plus offset, mid minus offset, done. This is fine. Which is better, earlier or this one? Why is the earlier one better? Again, same thing as last time. That is easier to understand. Correct. Again, when you go from algebra and you're writing things down mentally or on paper and you're copying them out, That is the more natural reaction. But this is more maintainable and more readable. I mean, in the long term. Assume that whoever is reading this course is an expert in algebra, like they know polynomials at least, right? For them, this is not a problem. And again, slightly better, let's say. Now, let me throw another, wrench in the works. What if people come with equations which are not in the general form? I'm sorry, is this too low? Is it visible? Ax square plus bx plus c is equal to d, where d is not 0. What do we do here? Can we tell our users that you please decrement your c on paper and then put in the new value of c or something? We can do that, but that will be irritating. People like, okay, this is a bad library, right? Sorry? Correct. We can just change the value of c, right? So, let's write another function, let's say def solve, well, better. What should be the inputs here? A, B, C, D. Exactly. What now? C equal to C minus D, or, this is fine. Now what can I do? Done. We can save 4 lines of code here again. What to do? I don't want 2 functions. I want only 1 function. And it should cater to both cases. People will present equations in the general form. People will present equations in like the not general form, whatever. What do you mean by that? No, that will just, Python will basically just not run. They will just complain that, okay, you have 2 conflicting definitions of the same function. Correct, correct. Essentially that, can we do better? Default values, exactly. This is something specific to Python, right? These are the affordances of the language. Python lets you do this. So, I can just do this. I can do solve ABC, I can do solve ABCD. D I don't have to provide. Why can we do this? Because default values are supported. They are not compulsory, they are optional, right? So again, here is an example of how you can use certain affordances of the language. The language has a set of features, right? Which you can use. Of course, you have to discover them because, ask ChatGPT will probably not discover it. But if you specifically prompt in a very specific way and you say that, I really want, I want you to write idiomatic code. And this is the definition of idiomatic. Idiomatic programming is understanding the affordances of the language. What is it that the language lets you do? What are the features that you can use, right? And it varies from language to language. And when you have, like, let's say, for example, when you do Java and all, you'll see certain differences. And after a while, you'll start, who's done Java by the way? Programming diploma people? You finished or? Okay. So, you see, when you do MAD 1, MAD 2, you'll be thinking in JavaScript all the time. When you do Python, obviously you're obsessed with Python. When you do Java, you start obsessed. You look at everything as object-oriented programming. And by the time you finish your programming diploma, all of these things will make a massive khichdi in your head, right? But that's a good thing because then you are now qualified to compare the merits of different languages and frameworks and where they apply, right? That's a good thing. So there we are. Idiomatic programming and craftsmanship is all about knowing the affordances of your language, what the language lets you do and exploiting that. And a corollary to that is that your code should be something that other people worry about, not you, right? Not in the bad way, it shouldn't be a headache to use for people. But good coders always make sure that their users are empowered and the responsibility of using your code properly lies with the users, right? Of course, if there are bugs, that's a different story. So, I'll tell you why I came to this, what inspired me to do this talk. Last year, around, why do the December of 2022 or something, when the first batch of diploma was graduating. When anybody here whose roll number starts with 2 on F1 except Dhruv? Well, you, first batch, right? So, most of you must be 2F2 or something like that, right? So, I think it was in May 2022 or was it 2020? Sorry, December 2022 was when the first batches finished, the first students finished their diploma. And at that time, what happened is we were being encouraged to do one diploma at one time, and if you enter the programming diploma, you finish it, then pick up the data science, or the other way around. And that was because they said that if you do this, then 6 months later you at least have something, right? Not like you learn both diplomas after one whole year, right? So I was talking to a bunch of students who had finished the programming diploma, and they were sitting together with a bunch of students who had finished the data science diploma. So, and this is basically the idea of what I told them, that, you really need to talk to each other. Because certain things in programming are very obvious to data scientists, and certain data science things are very obvious to programmers. And they don't know it. And when they don't know it, it looks like magic to them, right? So, ensure that you talk about whatever is obvious to you. There will always be people to whom it is not obvious, right? So, this is you know what the syllabus is, right? What does, diploma in programming really mean? It means that you can work with database. If you have a diploma in programming, and let's say that you're above average in the sense that you've never gotten less than a B or something like that in these courses. I know that, or okay, let's say 1 or 2 courses here and there is fine, but generally you're good, right? You graduate with 8+ CGPA, right? If you come to me with that information, and since I know about the content of the courses, if you've done a diploma in programming, I know for a fact that you can work with databases. You can write SQL, you can do database administration also to some extent, right? You know data structures and algorithms well enough, way more than is actually required for the job. You know modern application development, which means that you can do back-end development, you can do front-end development, you have done projects, you know how to deploy things, all of that. You know object-oriented programming, and you can work with Unix. When you do a diploma in data science, I know that you know algorithms, machine learning algorithms, you know linear algebra, you at least know the mathematical foundations of it, and you know tools for data science, so you can pick things up, various different things that you can put together and do a task, right? How do you make these two set of skills complemented? Like after you've done diplomas, most people enter that, state of existential dread. It's like, I learned something here, I learned something here, I don't know what to do with them together. How do I've done 4 projects, 2 in data science, 2 in programming. What can I do together? Like if I actually wanted to put together MLP and MAT2, what to do? Right? And the answer is not easy, of course. The question here is, how do you make these 2 skills complementary? And that is when I did this talk to this bunch of students on being creative with ML projects. Right? Their biggest problem at the time was, no matter what I do, my Kaggle rank is not increasing in my MLP project and stuff. So what can you do to be creative with them? And not just that, ultimately that project has to go somewhere. No? And your ML models cannot stick to the Jupyter notebook. They have to leave, and they have to live in the world also outside. And this is what I realized. Data scientists, not just the trainees, but even professional data scientists, even people as senior as 5 or 10 years in the field, they're really bad at uncertainty, which is very, counterintuitive. These are exactly the people who should be comfortable with uncertainty. What that means in programming terms is that their functions will fail randomly. There are two kinds of errors that we see in runtime of software: systematic errors and random errors. Errors that happen precisely when something specific happens, right? And then errors that happen randomly. If the errors are systematic, you can do something about it, because you can recreate the reproducible errors and the irreproducible errors. You can think of it like that. Data scientists are bad at both of them, generally. Data scientists are bad at asynchronous programming. You try to open somebody's Jupyter notebook, jump to the 9th cell and run it, and see how they react. And I actually did that in a Viva once, and this fellow was really upset actually. So, anyways, and I said, yeah, this fellow had also done the Mat 2 diploma just the previous term. And my simple question was like, you give me your web page, I'll go and click anywhere, right? You won't say that, no, please click on login first. If you're giving me that web page, I'll click anywhere, and users will click it. Users are dumb. Okay, that's, assume that. You need to sort of guide them towards the right path. So, why doesn't the same asynchronicity exist in data science project? I admit I was being a bit unfair. In a Jupyter notebook, you would have to be crazy to jump to the nth cell and run it. It's presented in a format for a reason, but the thing is that we tend to get married to that format. We get too zealous about it, right? Asynchronicity means functions are not always called in the right order, in the intended order. In fact, there is no intended order. Programmers are good at this stuff. These are my functions, call them in whatever order you want. If you fail, that's your problem, right? That fault tolerance is not there when you do data science programming for data science. Right? Data scientists are also bad at remote and distributed resources, which means that whatever caused a problem may or may not exist when you look at the logs later. If I leave my model running, this has happened with everyone. Google Colab runtime disconnected, I have no clue, right? Remote resources will disappear. Nothing you can do about it. Even if you pay for Google, by the way, it will get disconnected one day. What do? You cache results, right? Now, that is not something that occurs to you on day one. You have to develop that habit. Because most of my code, my libraries, my MLP or my pandas or whatever it is, scikit-learn, by default, it won't do it, right? Like those things won't necessarily cache things to disk or something. So, you have to use your own creativity to sort of add these wrappers around them to make it fault tolerant. Later, you will figure out, I leave my model running on Kaggle, next day, no submission, right? What happened? I don't know. I look at the logs, oh, okay, maybe there was this timeout which I should have increased. I should have had a Google Colab Pro perhaps, I don't know, right? And that's the thing. These are the things that data scientists are bad at, developers are good at this stuff. I'm talking about experienced data scientists and developers, and which is what leads me to believe that data scientists can actually make their life a lot easier if they start acting like developers. If you start believing that your deliverable is software, not simply charts or models or analytics, you'll be a lot better off. And how do you do that? That's where idiomatic programming comes in. Knowing the affordances of your language. Right? What this again means in programming terms is developers being good at uncertainty, which means that they know how to handle their failures. You don't have to take notes, by the way, I'll send you the PDF. In Java, for example, if your function crashes and you don't tell the compiler that it can crash, it won't let you compile things at all, right? In Python, it doesn't matter because, and the worst of all is JavaScript, where like it'll crash, it'll run, God only knows what will happen. Help yourself. So, uncertainty for developers means that they know how to handle failures. Asynchronous means they know how to handle stateful system. When a function is called, your RAM might be in a specific state, your files might be in a specific state, your databases may be in a specific state, right? If I write a function to load the latest model which is trained on some spam classifier or something, that model may not exist, right? I have to assume that there are stateful things outside, which again is very contrary to what we are taught in Mat 2, which is to develop stateless systems. Stateless doesn't mean ignore the, assume that stateless systems. It means that just keep in mind that there is a state which you need to account for, right? And once you have accounted for that, that means that as good as the state doesn't exist, the function will take care of itself. And what developers do when they handle remote and distributed systems is that they are good at working with file systems, cloud resources and databases. Right? They are not simply going to say that, no, I want an index.csv or an iris.csv only and nothing else, right? Data can come from anywhere in any format. So one fellow got really emotional because if they can handle uncertainty and if they can be asynchronous and if they are remote, and like how do they sleep peacefully at night? Like if they are allowing any and everything, like they sleep peacefully at night because they make their code somebody else's problem. Whoever disconnects the runtime has actually given you enough warning that that may happen, right? Nobody actually sitting there and disconnecting your collab runtime, of course. And this is, how do you make something somebody else's problem? When you do object-oriented programming, again, you'll figure out that there's this metaphor called indirection or subroutines, essentially. It is the ability to reference something by using a name, reference, or container instead of the value itself. This is also called abstraction, right? You are abstracting away one entire layer and you say that, okay, now it's not a very real thing, it's sort of a mental tool to help you organize your code better. So for example, when we deleted that Q class, which was it, and it was given over to collections.deck, that was an abstraction. I do not care about its details, whoever developed it knows it works. And this is one, we're not sure exactly who this quote is attributed to or who actually said it. It's likely nobody said it, but we can solve any problem in computer science by introducing an extra level of indirection or abstraction. And in software, everything is somebody's API. See, it's always like layers and layers and layers upon abstraction. So for example, if a graphic designer is giving me a Figma chart for a website, that's an API for a front-end developer, right? The code that I write is also an API for a front-end developer because they'll be using those APIs to actually build the front-end. The database administrator is giving me access to tables, that's my API. Based on that data and those resources, I'm supposed to build my backend, right? So everything is somebody's API, that's the takeaway here. Now, how do developers make their code somebody else's problem? By documenting and communication, right? So they communicate the intent, and we have violated that rule so many times in the code that we itself wrote. Function names, variable names should clearly communicate your intent, right? We should not be calling functions as, I don't know, solve or whatever. Should be calling solve quadratic equation or something like that. Solve, at least do solve underscore quad or whatever it is, right? Dijkstra is a bad name for a function. If you're doing Dijkstra shortest path algorithm. Shortest path algorithm, in the doc string you write this uses Dijkstra's algorithm. Dijkstra is somebody's name, right? It's not a verb. Functions should be verbs. The names of functions should be verbs. And the names of variables should be nouns, right? That's sort of the rule of thumb. And how do you communicate intent? First of all, have an intent. Having intent is itself the biggest part. Like you have to be, and it's perfectly fine to be opinionated about your code. It's like my code is going to do this. It will not do certain other things. If you really want me to include certain things, feel free to raise a request or something like that. So that's what I mean. Cultivate the desire first and the means and the will to communicate intent. But unfortunately, willpower depletes. So you have to make it a part of your process. Typically what we do is when people check in their code, if there are no doc strings, their code is automatically rejected. So there is not a question of willpower, it's now a part of my process. They have to write documentation, right? And again, there's the desire, the means and the will. You desire it because it is actually good PR. In the sense that, people will use your code obviously and you might forget what you wrote about it. 3 months later, it happens all the time. Like, I'll go back and, something has broken and I'm spending the entire day trying to debug some code and like, okay, which idiot wrote this piece of code? And it turns out you look at the Git logs and it was you yourself. Right? And that's because, developers also evolve over time. Like I've learned patterns just 3 months ago, which I would never have used 3 years ago. Right? So that happens all the time. The means of doing this can be practiced and taught and learned. So how do you, the means of communicating intent are obviously doc strings is there. You could go and talk about your libraries, you are in the middle of a community and you always, do code reviews with people. There are many various means of communicating intent there, right? And this is what I said earlier, always be building interfaces. All your code should be an interface for someone else. which is what I demonstrated through the quadratic solver problem. It's an interface which is available for both these forms, doesn't matter, as long as it's a polynomial. One case we did, now that I remember, one case we did not cater to is the roots not existing, I think, right? Now there are complex numbers in Python, but I think that code doesn't handle that case, it will probably crash or something. We will try it out later. Okay, everybody is a programmer, even graphics designers are actually programmers. They are taking somebody's API and they are creating something out of it, right? In a sort of, they are telling a computer what to do, which means that they are programming. Always remember this, everything is somebody's API. Now, you must have heard, how many of you have heard of Keras? The author, Francois Chollet, he was at this conference called Anaconda Con 2019, how to win developers' hearts with highly productive tools, like why Keras and scikit-learn are these really great tools. And he prescribes this 3-step process, deliberately design end-to-end workflows focused on what users care about. So when you do scikit-learn, it's not like, they'll say, read your data in a separate repository or separate package, or, then, do pre-processing. Something is, I will only do machine learning. It's not like that. There is an end-to-end pipeline. There is a reason why pipelines exist in scikit-learn. You can do pre-processing, training, post-processing, bunch of other stuff, right? All together. One example that he often gives is, how many of you are Unix or Linux users? Okay. Who remembers the command to untar a tarball? tar.gaz or something like that. Yeah. What's the X is extract, V is verbose, I think F is file or something. XZVF. For the life of me, I cannot remember that properly. I have to look it up or at least think for 30 seconds before I can come up with the right word. That is an example of bad design. How do you unzip a file? Literally just unzip -D. That's always CP, MV, all of these things are quick, right? But there is this one thing called tar which has like a, of course, I mean, you could read the manual and your brain is not meant to memorize these things. With practice, it becomes easier. But that's the example of, having an extremely non-intuitive interface. It doesn't, it would be a lot better if I could say something like tar -- extract or tar -- compress or something like that. But no, for extract, the abbreviation is X, it's not E. And for compress, compress is C to be fair. So yeah, and then reduce cognitive load on users by providing good feedback. When you see Python errors, so like show. Typically the tendency, and this typically happens again with students, when we see a traceback, something crashes, you panic and your mind goes blank. You have no idea how to read it. But let's take a look. In fact, let's do it right here. This clearly doesn't have solutions, right? Does that make sense? I mean, all I'm thinking is like my offset is so large that there's no way solutions can exist for this. This is an example of a terrible error message. What does this tell you? Math, what is math domain error? It doesn't mean anything, right? But anyway, I mean, the point was to help us understand how to sort of read error messages. This is the type of error that happened. You probably know various types of error. This is simply a string that is called the error message. This is the line which is where the error happened, right? It's line number 7 in solve. What is solve here? Solve is a function. So line number x in y means x is the integer and y is the function when which happens. It also tells you which file that function is in. Because I could, be importing library after library after library. And in line number 11, I was calling it. So this is how you read a Python traceback, right? And what the thing to take away here is that sometimes people panic so much and they just keep running the same code in frantically again and again, hoping that it will randomly work. This happens especially in vivas and interviews. Do not fall for it. Please be very careful about it. The thing to note is that these error messages are not randomly generated. They are written by humans, which means that they have a meaning. They are supposed to have a meaning. The fact that this one doesn't is bad. Maybe, I don't know, they probably had good reasons for writing something like this. But what, I mean, the normal way to write this is like no roots exist or simply something cannot find square root of negative number, right? Something like that would be better. So, write good error messages. In fact, if we were to do that, what we would do is I'll in fact raise the value error again, but this time with a different message, right? Hey, how do you do this? Is it a class callable or something? You see, it doesn't hide the previous error. It actually shows you in the traceback. So this is more readable, right? Anyway. Other takeaway, biggest takeaway is that modularity, testability and readability are actually the same thing. The shorter your code is, the better you will be in readability also over the long term. Because what happens is teams that work together, they'll reach a level of maturity sort of soonish, right? And then you, if there is a junior person in your team who has just joined and they don't understand, let's say, list comprehensions or dictionary comprehensions, and they insist on writing for loops all the time, that's perfectly fine. In fact, you could also argue that for loops are more readable than list comprehensions. There's no very strong evidence for one of them. But later you will find that these same people will later become very comfortable with list comprehensions eventually, right? Because people get better. Most people get better over time. And it's only modular code that can be readable and testable. So, how do you write readable code? There's a process for it. This is the Dijkstra's implementation as provided in the PDSA lecture, right? And see, one of the code is just terrible. Okay, it's absolutely crazy code, and I'll tell you why. They actually implemented something called infinity. Why would you do, and how did they find that value of infinity? By iterating over the adjacency matrix, finding the largest value and doing +1. Which is an order of an operation by itself, right? It's completely pointless. Infinity for us in the context of Dijkstra's shortest path is simply a symbol. It's a number, not even in the abstract mathematical or number theoretical sense. It is simply a number which, when compared with any other number, turns out to be greater. That's all. That's what we mean by infinity. So we just need a symbolic interpretation of infinity. Math.inf is perfectly fine. And you will see the crimes against humanity in this code, basically. And to be fair, I don't think Professor Madhavan actually wrote this code. Because he, being the Java developer that he is, he's no ways has written this code. I don't know who wrote it. Thankfully, I don't want to find out either. So look at this. If next v list equal to an empty list, that's just terrible. Visited distance is equal to empty dictionary, comma empty dictionary, and there are parentheses around it for no reason, absolutely no reason, not required. When you are doing tuple unpacking, you do not need extra parentheses pairs. Yeah, so many other ways that you can make this better. But the pleasure of, or rather one of the pleasures of listening to Madhavan Mukund is that he says exactly what he intends to say. He will never stutter in the middle of a sentence. And the way to go through this course, PDSA people, is do not look at the code. Actually close your eyes and listen to what he's saying in English. He speaks so precisely that what he is saying might well be your pseudocode. And then implement that in Python. And which is the only reason why I was able to score an A in PDSA or something. Barely. But if I went by the code that was being shown, like my 11 years of Python experience was not helping me figure this out. Right? So the process for readable code is first try and have a natural language abstraction for code. Narrate your code to someone. Have a human listening to it, talk in some natural language. English is recommended because Python is close to English than some other language. And that's the whole point. There is code has to be communication. Donald Knuth very famously said that the primary purpose of code is to communicate with other people. The fact that it actually runs on computers is just coincidental. And you know that computers will run terrible code also. Hardly matters. But primarily, it is humans who will be dealing with it. And the other way of saying this often is, it is easy to scale silicon, but it is difficult to scale carbon. So, organic matter can't automatically become smart. So, your humans are more important resources than your compute, right? So, here's the process for readable code. First of all, have some perfect information. If you don't know what you're doing, then trying to make your code readable is equivalent to premature optimization, which we do not want, right? And then you decide on the level of abstraction, like that indirection slide, if you remember. Do you want to work at the algebraic level, or do you want to, work at a polynomial level or whatever it is? Which level do you want the user to work at? Which is, I think, one of your points. Like, do you want to make it interactive? That's like the interface presentation layer of things. Do you want the user to make an interactive app that people can enter their coefficients and stuff? No, we don't. We want to operate at one slightly lower level. Says that we are just going to give a solver function, right? Atomic functions, clear and variable meaningful names. Any idea what atomic functions are? Who's done the databases course? PDMS. Acid properties, right? Do no harm. That's what it really means. Like, leave the world a better place than leave your computer a better place than you found it. Or in fact, if you can't do any good, at least don't do any harm. Your function should not go and corrupt something else. This is what data scientists do all the time, unfortunately. And finally, idiomatic programming means know your language and know the standard library. Knowing, and this is the sort of thing that LLMs are great at. Like, if you ask it, I'm still surprised by the kind of things that ChatGPT throws up, or Find, or any other Copilot. In fact, Copilot will, GitHub Copilot will suggest code that you will never think of, but the moment you see it, it completely clicks. I have spent about 12 years doing Python programming. To this day, I am realizing that there are things in the standard library that are there, that I did not know about, right? And until Python 3.10, the documentation page of the Python website, docs.python.org, they used to say that standard library is this huge reference book or set of documents that they have. They had this nice tagline there which says, keep this under your pillow. And long ago, like in the late or in the early 2010s, O'Reilly actually used to publish that standard library as a book. Nowadays, obviously, nobody cares because, you don't have a huge book lying around while you're coding, right? So, it's all online. But they used to actually, O'Reilly is that publisher which has animals on its covers, right? So, they used to have this huge Python book, which was essentially the standard reference. And it was so big that, on the cover itself, it said, like, we know that the official doc says keep this under your pillow, but it's so big that you cannot keep it under your pillow, use it as a pillow. It was a huge book. And that's why that the standard library is so big that you'll keep discovering new and new things all the time. Anyway, this is slightly irrelevant. Let me check if, some results from the scale. Sorry, are we out of time or something? These are some research results on code readability and modularity that have been done. First big takeaway is that the biggest predictor of code complexity is lines of code. And this is independent of language, this is independent of operating system, this is independent of the skill of people. No matter what it is, more lines of code is always worse. It's always more complex, often more complex than what you need. There is something called semantic entropy. We know about the concept of entropy, right? Semantic entropy is entropy in the meaning of it. Like if your code is arbitrarily becoming more and more complex without communicating intent or, making itself clear, that's semantic entropy. Programmers spend most of their time talking to each other about, code debugging, which is bad. And it turns out, like when you go to an organization and try and do the study, which we also did, they'll be asking the same questions over and over again. So this is sort of the place where you can consolidate that and create an FAQ, right? And there is one other rule, that always be very suspicious of other people's code, except you know exactly what it is. That's what we mean by upstream is always broken. So I used to work for this company. Who uses Conda here? Only 2 people, okay, surprising. So Anaconda is basically the current state-of-the-art default Python distribution, and before it became that, there was something called EPD, which is the nth Python distribution. And I used to work in the build system team of the nth Python distribution, and our job was essentially to build packages and sell them to people, because the free and open source packages that nth provided, they were free, right? And we had this rule that upstream is always broken. What this means is that whatever you find on GitHub, and this, by the way, is like 12 years ago, so there was no pip. There was to be this very terrible thing called easy install. It was not at all installed. There used to be jokes like, the Python package manager should be called maybe. Maybe install something, maybe delete something, maybe uninstall or update something. And Python packaging was based on a file format called eggs back in the day. Nowadays it's called wheel, WHL, right? It was a Python lays eggs and all sorts of weird jokes people had about it. So the rule that we had there before we sent out any packages, before we released any packages to clients, is that the upstream is always broken. And we used to build packages, 6 different versions of a given package, 32-bit operating system, 62-bit, 64-bit operating system, Windows, Linux and Mac OS. So 6 total. One of them will always be broken, no matter what you do. In the 3 years that I spent in that team, I remember exactly 3 libraries that did not require a single patch. Any guesses what those 3 libraries were? Only 3 Python libraries that I know of while the nth Python distribution existed, which did not require a single bug fix patch. Guesses? What do you think they are? Sorry? No, not built-in libraries. You hardly need to do anything because you don't even sell them. They are all for free. Not built-in libraries. Modules, Python modules. The first one was IPython, not Jupyter, but IPython, the project itself. So this thing. There is something called meta programming, which is programming for programming. It's like if you actually, in Java it's called inspection. You try and grab what is already happening in your code. IPython source code has amazing examples of how to do meta programming in Python. The other library was requests. It's very simple. It's amazingly well written, and just generally, if you want to see the kind of beauty people can create with standard Python stuff, go and read the source code, and it's actually very readable. Request is actually a very simple library. Before that, there was this thing called URL-lib3. It's still there. It's pain to use. Right? And the third library, which never required a single patch, is scikit-learn. Their use of abstractions and interfaces is so amazing that it will actually make Java programmers jealous. Fantastic library. So these are places where you can look for in order to learn idiomatic code and good software craftsmanship. Okay. This is something that you can always remember. A good piece of code is one that can be deleted easily. And I'm saying easily, not without consequences, but the consequences are predictable. Any code which you can confidently delete is good code. It's not long code, it's not complex code, it's not nothing to do with that. Just apply this test all the time. if I delete this piece of code, do I know what will happen? And if the answer is yes, it's a good piece of code. If your answer is don't know, but you know, you always have these jokes like, I don't know what I did, but if I don't do this, it crashes. That's bad code essentially, right? So there we are. We're almost at the end. I think, yeah, that's about it. Any questions or need anything at all, feel free to, okay, I don't think I have left my email address with you, but actually, this is better. Is it ds.study or study.ds? I keep forgetting. Huh? ds.study, right? So, if you need access to the slides, let me know. I'm happy to share it. And if there are any questions or anything, I'll be happy to take them. I'll be around for the rest of the day. Find me wherever you like. All right. Thank you.